When I have the limit, let's say from 1 over x minus 2 squared when x approaches 2. Let's say I'm asked to determine this limit. What do I have to do first? Anyone? Please talk to me. Even if you're wrong, it's okay. I'll give points for talking to me even if you're wrong.
Do you factor the but? Never mind.
Simon, say it again.
Do you insert 2 or
yes,
do you factor?
Exactly. So the numerator is going to what? Anyone?
0?
But do I have 0 here?
No, I thought you said that I went to the bottom.
Oh, yeah. I'm sorry. The numerator?
1.
That's it. So I know that this is a big deal. This is a problem, right? Problem, correct? Why? Because I don't know what to write. I don't know if it's infinity. I don't know if it's negative infinity. I don't know if it's D and E. So what is the problem then? The problem is the fact that I don't have positive or negative here. So this is from either side. Oh, if that's the case, because I've noticed this in your work. So maybe I did not emphasize this enough. So as you know already, I always blame myself first. Okay, so when my students make a mistake, I always say, did I say it? Did I did enough? Did I? Okay, good. So if that's the case, and if the limit is from either side, number one, I have to find the limit because I cannot decide. That's the problem. I cannot say this, this, or this in this situation. So I have to find the limit like we just did here with problem 83. Donovan, was this okay? I'm sorry, I forgot to ask you. Was this problem okay for you?
Yeah, I copied it down.
Okay, but do you feel better after doing this?
Yes.
Okay, perfect. Thank you. Okay, so I have to find the limit as x approaches 2 from the left of 1 over x minus 2 squared. Number 2, I have to find the limit as x approaches 2 from the right of 1 over x minus 2 squared. If this gives infinity, and if this gives negative infinity, what do I write for the final answer? And number 3 will be the final answer. What is the final answer? Exactly. Very good. Who said that? Thank you. Simon, very good. Okay, so now, how do I determine these limits? And then finally this one. I cannot make a conclusion. It's a number over 0, and I may have any of these situations. That's the reason why, because now if it's only from one side, I don't have to do this. But it's not from one side, it's from either side. So therefore I have to determine both. Good. So 2 from the left. 2 from the left, imagine that you plug in here 1.9. 2 from the left, 1.9. 1.9 minus 2 is a negative number, close to 0, and you square it, it's positive. So 1 divided by positive will be infinity. We know it's 0, so it has to be one of these for each. Either this or this or this. But since this is a positive number because 1.9 minus 2 is tiny, close to 0, but negative. But when I square it, I get positive, so that's why it's positive. Now with 2 from the right, this will be with 2.1. Same situation because I square. So it's still positive. Therefore, the limit I'm interested in is
positive infinity.
That's
oh, no,
it.
I thought, yeah.
That's perfect. So also from here, I know that x equals 2 is what type of line? X equals 2 is what type of line? If both sides go to infinity, both sides, the limits are going to infinity. What is this? Yes.
Vertical line?
Asymptote. Exactly, for this function. Okay, enough of that. So I'd like us to go back to 1.3 and 1.3 to practice. We did practice one problem last time.
I'm sorry, I have one quick question.
Any question?
On
Sure.
that third part of it where it says x minus 2 squared equals positive infinity, is it equaling positive infinity because the other two had the same behavior?
Exactly. If
Okay.
one of them is negative and the other one is positive, I cannot write this. I will have to write DNE.
Okay.
But because they are both the same, I have to write infinity. To be honest, all of them are DNE. But I cannot write DNE unless these two are opposites. We know that a symbol is not a limit. So that's why I'm saying that this is not, does not exist, but I have to write the way it does not exist. Okay, back to 1.3. Let's take a look on page 135. 134. Okay, so let's take a look. I'm going to share my screen. Where is my book here? I found it. Where is my share button? Sorry, my device is so far away that I have to go around it. Okay, so we're in, I said 134. Where's my keyboard now? 134. Okay. Sorry, guys, you are in the way. Okay, so let's read this question. Find the simplified form of the difference quotient, and then complete the following table. This we have done before. Let's quickly look at an example. I don't know. 35. Okay, so let me copy it. F of x, x squared minus 3x plus 5. And we can plug in all these x equals 5 and all these. We're just going to choose whatever. So we don't need to spend time on all four of them. Okay, so for now, they're asking us to determine and simplify the difference quotient. Can anyone give us the difference quotient?
F of x,
The formula for it? I'm sorry.
Yes.
F of x plus h minus f of x over h.
Excellent. So we did this before. Just quick refresher, because I need it in the next section anyway. This is done. This is done. What is the only one that I don't have yet?
F of x plus h.
Excellent. Good. So remember what this function is telling us. Blah squared minus 3 times blah plus 5. So again, we did this before. Let's do one more. So can anyone tell us how to start this?
Replace x with x plus h and f of x.
Excellent. Done. Can anyone give us this formula, please?
X squared plus 2xh plus h squared.
Brilliant. Minus 3x minus 3h and plus 5. Is this color okay? Can you see this, or I shouldn't use it? Okay. So then I can, you know me, I'd like to continue where I'm at. Does anyone remember what are the things that have to happen every time we calculate and simplify the difference quotient?
Do we eliminate h?
From the top, all terms without h, the order is very important. All terms without h from the top will go away, and then this will go away, not the other way around. Okay. Any questions? Okay, so I'm copying, instead of this, I will copy all this. So x squared plus 2xh plus h squared minus 3x minus 3h and plus 5. Remember, now we are here. I have to distribute the negative sign to all three terms. or you put minus in parentheses. So negative x squared plus 3x and minus 5. Is everyone okay with this so far? Anyone needs anything? Any questions for me, anyone? Okay, then exactly what I just said has to happen. If it doesn't, then I have a big error somewhere. The remaining 3 terms must have age, because the next step would be what?
To eliminate, or
Factor
to
out.
simplify the h.
Very good. Factor out. Please do not simplify in a sum. Please show that you factor it out first. And now, what is left in parentheses? I have 3 terms. I have to have 3 terms here.
2x plus h minus 3.
Excellent. Thank you, Sarah. Now, this is the second thing that has to happen in this particular order. All terms without h go away, and then h from the denominator goes away, and this is final. And now they're asking us to plug in for x 5 and for h different values. Do I need to do this, or can I skip this and you understand how to do it? So when x is 5 and h is 2, we are asked to determine the number. So when h is 5,
It would be 9.
so this will be, yes, so 10 plus 2, exactly. So the difference quotient will be 9. So 10 plus 2 is 12 minus 3 is 9. So this is the first. Now you're asked to plug in 5 and h point 2.1 or whatever, and you determine the number. Can I move on?
Yes.
If you
I
need,
swear I mean to keep muting as soon as I talk. I know it's loud in my house. I'm so sorry.
that's okay. Good. So I would like us to look at a word problem. So let's say I use the following graph to find the average rate of change in U.S. median household income from 2010 to 2012, or 12 to 15, or 2010 to 15. Choose any of these, and you can repeat for the other 2. So just choose any of the 3. 10 to 12, 12 to 15, or 10 to 15. Any.
12 to 15.
Okay, very good. Good choice. So 12 to 15. So now this is 45 on the same page. So let's read for years since 2010. Since we chose 2012, then we're going to have to look at this. So I see 2 comma, I think it's 52,700. So 2 comma 52,700, and we said 15, so that's 5 years later. 56,500. So 56,500. Good. So I'm going to stop sharing. How do we determine the average rate of change? So before we do that, so one more time. So this is in years, the x variable is in years, and the median household income in dollars. Okay? Very important. So y in dollars, x in years. Crucial to remember this. You'll see in a moment why. Okay, now, so can anyone give us the formula for the average rate of change?
Change in y over change in x.
Perfect. And the formula is?
y2 minus y1
Very
over
good.
x2 minus
Yes,
x1.
f of x2, exactly what you just said, over x2 minus x1. Same thing. But we want to emphasize that this is the function value, but it's the same thing. y2 minus y1, that's what it is, over x2 minus x1. Perfect. So can anyone dictate what I should write? Anyone?
You would do the 56,500 minus the 52,700
Excellent.
over 5 minus 2.
That's it. Okay, can anyone give us this calculation so we can move on? Let me just
3,800 divided by 3.
Let me just show this because I would like you to understand with a graphing calculator, you must put parentheses. So please don't do step by step. Put everything in from the beginning. 56,500 minus 52,700 in parentheses for the top always, and divide by, since the denominator is 5 minus 2, I'm just gonna write 3. So this is it. I'm going to round it to 1266.67. Now, if I omit the measurement unit, I will get points off. The measurement unit for a ratio like
Would it be
this,
dollars per year?
brilliant. So if I omit to say, first of all, it's an increase of $1,266.67 per year from the year 2012 to 2015. That's what happened. The average income increased by $1,266.67 per year. So if these were abstract, no dollars, no years, nothing, then I didn't have to write anything. But if y, which is the variable at the top, is measured in dollars, and x, which is the variable in the denominator, is measured in years, the answer must have a measurement unit. Actually, it has two, but this is one measurement unit for this number, dollars per year. Make yourself a note. If I forget to write the measurement unit, I will get points off. Please. Okay, moving on. Did we get the idea here, or do we need to work on more problems with the average rate of change?